Good morning. Now I am going to tell about the roadway fundamentals. This roadway fundamentals is used to find the distance traversed. So that means how much distance it is going to travel. So we know that the road will not be a smooth curve. So it will be having some ups and downs will be there. So you can consider the road as a two-dimensional part. So here observe this is the road which we are considering now. This will be having two dimensions. On the x-axis this is we are taking as xf, and on y-axis you will be taking as the function of x of xff. And here for solving this roadway fundamentals you need to consider two unit vectors. On the x-axis, the unit vector you will be taking as I bar, and on the y-axis you will be taking as j bar. So this is a fixed coordinate system, and this is the roadway on the fixed coordinate system. So now in this two-dimensional roadway can be described as yf is equal to f of xf. For this, the position vector between, we know all from the EMF, between 2 points A and B, the roadway position vector can be denoted as R bar. R bar of XF is equal to XF into I bar plus F of XF into J bar. So this is the X coordinate and this is the Y coordinate. And this is the unit vector IF, and JF is the unit vector in Y direction. And this is from A and between A and B points. The tangent vector can be derived by T bar is equal to derivative of the position vector d by dx of R bar. That is equal to, so derivative of x with respect to x is nothing but 1. So 1 into if plus d by dx of f of x into jf. This is the tangent vector. And the distance norm of this tangent vector can be calculated as the magnitude. So the magnitude is nothing but the square root of x square plus y square. That is 1 plus df by dx whole square. To get the distance traveled, you need to take the summation. So for the summation, you need to go for the integral. So integral from points A and B of the magnitude of tangent vector t bar of x into dx of x. So from this we have already calculated the distance now. So this is the total distance traveled. Now from this you can also consider the grade. What is the grade? Grade is nothing but the vertical rise per 100 horizontal distance of roadway. So that means if you consider this as the roadway, vertical grade means the y-axis y coordinate divided by x coordinate. That is here the y change is nothing but delta y, and the x is for 100 meters you will be taking as 100 m into 100%. That is equal to delta y percentage. Now the tangent of the slope angle is nothing but tan beta. Tan beta is equal to delta y by 100 meters. And the roadway percent grade can be described as beta function, that is beta of xf is equal to tan inverse of df by dx. And this can be derived from the laws of motion from the Newton's second law. So this Newton's second law is nothing but the force is nothing but m into mass into acceleration. So this m is nothing but the mass of the object and a is the acceleration of the object. So from there are different forces acting on a object. So the total force is nothing but the mass into acceleration. So we will be using this for the deriving the next topic. So the power input to the particle for I force is nothing but P is equal to force into velocity. This force into velocity is nothing but you will be considering the x direction. So that is nothing but V cos theta, where theta is the angle between the force and the resultant velocity V. And the units of if J is the polar moment of inertia of the rigid body, then the rotational form of Newton's second law of motion is sigma t is equal to J into alpha, where omega is equal to angular velocity, alpha is equal to change in the angular velocity, that is d omega by dt, that is nothing but d square theta by dt square. So this alpha is nothing but the angular acceleration. So from this, the power input for the ith torque is nothing but Ti is equal to torque into angular velocity. So the torque is Ti into angular velocity is omega. So this is the power input for the ith torque. Next topic is vehicle mechanics. So this vehicle, for deriving this vehicle mechanics, you will be considering the Newton's second law, which we have discussed now. This mechanics is nothing but the combination will be having kinematics plus dynamics. So in this kinematics, dynamics are used to derive the tractive force. So this tractive force is the force from the propulsion unit, which can be an electric motor or an IC engine or a combination of these two. So because of this force only the vehicle will be moving forward. So this force is nothing but the tractive force. And the vehicle kinetics is nothing but it is a branch of mechanics that concerns the effect of forces and torques on the motion of bodies having mass. Let u of x or x is the unit tangent vector in the fixed coordinate system pointing in the direction of increasing xf. Therefore, the unit vector u of x is equal to this vector divided by magnitude. So that here the vector is nothing but t bar of x, whereas the magnitude is delta of t of x. That is equal to, here vector is I plus df by dx into j. Magnitude can be considered as the square root of x coordinate square, that is 1 square plus df by dx whole square. And from the Newton's second law of motion, F is equal to m into a bar, that is a is nothing but the acceleration. Acceleration is nothing but the change in velocity, that is m into dv by dt. And the components of this coordinate system are component tangent to the road. So when the vehicle is moving on a road, there are three forces acting, that is in the x direction one force, and the y direction another force, and z direction another force. Considering the x direction, the force acting is f of x of t, that is equal to m into velocity in the x direction, that is dvx by dt. Whereas in the y direction, fyt is equal to m into dy by dt, dv of y by dt. And in the z direction, that is f of zt, that is equal to m into dvzdt by dt. We know that the vehicle is moving in the x direction, so there will be velocity in the x direction only. So there are no velocities in the y direction or z direction. So the forces acting in the y direction and z directions are 0. So there is only in the force acting in the x direction only. So the component normal to the ground fyt is equal to 0, and also in the z direction also the force will be 0. So there is only one force acting in the z direction, y direction, in the x direction. So now see, consider this as the object. On this object there are three forces acting now. So those forces are nothing but, one is the gravitational force, the other one is rolling resistance force, and the other one is aerodynamic force. So that FRL tractive force is equal to FGXT plus F rolling resistance plus FEAD. So FGXT is nothing but the gravity force, F roll is nothing but the rolling resistance force, and FEAD is the aerodynamic force. So FGXT, we have already calculated this FGXT, that is m into dVXT by dt. And this rolling resistance force and the rolling resistance force can be calculated as, from the formula, F roll is equal to, this is the signum function, signum of mg of C0 plus C1 Vxt square if Vxt is equal to 0. If Vxt is not equal to 0. If Vxt is equal to 0 and Ftr minus Fgxt is less than C0 of mg, then the force will be equal to Ftr minus Fgxt. If Vxt is equal to 0 and Ftr minus Fgxt is greater than C0 mg, then the force is equal to signum function of Ftr minus Fgxt into C0 mg. And if the signum function is nothing but it will be having a value of 1 if Vxt is greater than or equal to 0, and is equal to minus 1 if Vxt is less than 0. The aerodynamic drag force is the result of air working against the motion of the vehicle. So when the vehicle is moving on the road, there is some amount of force which is making the vehicle to move backwards, that is which is opposing the motion. That force is nothing but the aerodynamic force. That aerodynamic force is given by FAD is equal to signum of Vxt into 1 by 2 rho CDAF into Vxt plus V naught square. So now from these three we can calculate the total force, that is the gravitational force plus aerodynamic force plus rolling resistance force. So these are the three different forces from which you can calculate the tractive force. So in the formulas we have used rho. That rho is nothing but the air density, and the units of air density are kg per meter cube, and CD is nothing but the aerodynamic drag coefficient, AF is the equivalent frontal area of the vehicle, and V0 is the headwind velocity. And coming to the dynamics of vehicle motion, the dynamic equation of the motion in the tangential direction is given as K into M into dVxt by dt, that is equal to tractive force minus road load force RL, FRL, FTR minus FRL. Generally, in the kinetics, this is 0, so there will be only one component FTR, that is equal to rolling resistance plus aerodynamic plus gravitational. But here in the dynamics you need to consider the difference between these two. So we are considering here the difference between these two, FTR minus FRL, that is equal to K into M dVx by dt, where Km is the rotational inertia coefficient to compensate for the apparent increase in the vehicle mass due to the onboard rotating mass. And the acceleration of the vehicle is nothing but A, that is equal to dVxt by dt. So this is the dynamics of vehicle motion. As we know, the velocity is nothing but change in displacement. Vxt is equal to ds by dt. So for modeling and simulation, the above two equations are required. So that means the velocity equation as well as the dynamic equation. From these two, you will be drawing the, you will be obtaining the modeling of these dynamics of equations. Next, force velocity characteristics. Force velocity characteristics is nothing but the graph drawn between the force and velocity. First we need to know what is the equation of force and then what is the equation of velocity. We know that the equation of force is given by the dynamics equation, that is Km into M into dVxt by dt, that is equal to FTR minus FRL. And we know that from the steady state velocity is reached to 0, so dv by dt is equal to 0. That means this is equal to 0. Then the only term is nothing but FTR minus FRL. So FTR minus FRL is nothing but the aerodynamic force, sum of the aerodynamic force, rolling resistance force, and the x direction force. So the FTR minus these three forces is equal to 0. That means FTR is equal to, this becomes to the right hand side, and if you substitute the aerodynamic force formula, rolling resistance force formula, and the gravitational force formula, then it will become like this. FTR is equal to mg of sine beta plus c naught signum of v plus signum of v into mg c1 plus rho by 2 into c naught af into v square. So that means this you can observe the FTR is proportional to the velocity square. Is proportional to the velocity square. That means the graph will be a parabola equation. And also you can observe the signum function, signum of v. So because of the signum of v, it is not a continuous graph will be there. There will be discontinuity of the graph. See, observe, there are 3 curves here, but you can see 6 lines are there. So here these 6 lines are nothing but only for the 3 only. So this is for beta 1, beta 2, beta 3. So for the beta 1 beta 3 you can observe, this is it will be a parabola, it will be in the shape of parabola, but at v equal to 0, it will be in the negative direction. We know that the signum function is nothing but 1 for v greater than 0 and minus 1 for v less than 0. That means it will be identical between the force axis, but it will be in the shape of parabola only. So the discontinuity of the curves at 0 velocity is due to rolling resistance force, which is having the signum function. So these are the force velocity characteristics. Okay, thank you.